Okay, today we're looking at factoring polynomials. You did talk about this some last year in pre-algebra, so some of it's going to be a review, some of it will be a little bit new. So basically factoring is going to be the opposite of multiplication, right? So we're going to be thinking about division, what can you factor out of each term, right? So like when I look at 27y squared plus 18y, and it's just asking you to factor that, you look at both terms and just think about first number parts. What can you divide both of those numbers by? 9 should be the first thing that comes to mind. If not, 3 would work too, but we always want to divide by the biggest possible number. Okay, so we know we can divide both terms by 9, and then we look at the variables. So what other variables can we divide both terms by? Would be 9y. All right, so then you would leave in parentheses whatever you would have left after you divide each term by 9y. So 27 divided by 9 would give you 3, and then if I take y away, then I would be left with just 3y. On the other one, if I divide 18y by 9y, that would leave me with just 2. Now, here's how you can think about it. If you took what was in front and distribute that back in, would you be left with your original answer? The other thing you should always check is whatever you have left inside parentheses, you need to make sure that it is in simplest form. Okay? Let's look at 15w minus 3v. So on this one, when I look at the number parts, 3 is the only number that I could take out. I can't take out a variable because one has w, one has v, so I'm going to leave those. If I divide 15w by 3, that's going to leave me with 5w. If I divide 3v by just 3, then it's going to leave me with just your variable, which would just be v. Okay, now this can also work if you have more than 2 terms, so we'll look at some that have 3 terms, which would be a trinomial. So if it has more than 2 terms, you need to be able to, whatever you're factoring out, you have to be able to factor from all 3 terms, right? So number parts, I'm looking at 4, 8, and 2. So I would factor out 2. And then from variables, I have a squared, a, and a. So the biggest variable I could take out is just a. And then each of them has b, so I'm going to take out 2ab. All right, remember, think about if you divide by 2ab or factor that out, what are you left with? So negative 4 divided by 2 would leave you with negative 2. From a squared, I'm taking 1a away, so that would leave me with just negative 2a. If I took b from that, then I wouldn't be left with anything else for b. All right, same thing on the next part. If I divide negative 8 by 2, I would be left with negative 4. I took my 1a from that. b, if I take 1 away, I would be left with negative 4b. All right, here's where you have to be careful on the last one. If the whole thing, if I factored out 2ab, if the whole thing factors out, you have to be left with something. So think about if you have a fraction, right? 3 divided by 3 would just leave you with 1. So same idea here. 2ab divided by itself is going to leave you with 1. A lot of people are tempted not to put anything back in its place. All right, let's do 7u squared t squared plus 21ut squared minus ut. All right, so again here I'm looking at what number can I take from all 3, 7, 21, and 1. Anytime you have 1 that that is the leading coefficient, then you would only factor out the number 1. Okay, so if I can't really factor out a number, what variables can I take from both? If I have u squared, u in the second, u in the third, I'm going to factor out just u only. And then what can you take from t squared, and t would be just t. Right, so remember when we're dividing, if I'm dividing something that has exponents, I'm basically just subtracting 1 from each of those exponents. So 7's going to stay the same, and that's going to drop it from u squared t squared to just ut. Same thing on my second term. 21's not going to change. If I take u away, that would cancel out, and I'd be left with just 21t. On my last term, if I factor out exactly what's there, ut divided by ut would leave you with just 1. Okay, so both of those ways show distributive property because if you factor out correctly, you should be able to distribute back in and get your answer. The other thing that might happen is you may have to factor by grouping. So grouping usually happens whenever you have more than 3 terms. So typically if you have 4, you're going to group them into pairs, right? So for example, if I have 4qr plus 8r plus 3q plus 6, I'm just going to group them in pairs, right? So I would group these first 2 together would be fine, and then I would group my second 2. Okay, so first thing I would ask is what can I factor from that first set of parentheses? I can definitely factor out 4. I can also factor out r. So if I factor out 4r, what would that leave me with? On the first term, if I take away 4 and r, it would leave me with just q, plus what? 8r divided by 4r would leave me with q plus 2. Let's give it a little loop so we know it's not a 9. All right, same thing on the second. Now, whenever you do factoring by grouping, whatever you have left in parentheses after that first time you factor, you want to be left with that same thing. So think about, what would I factor from 3q plus 6 to be left with q plus 2? Well, really the only option you have is to factor out 3. If I factor out 3, that would leave me with q plus 2. Okay, now from here, if you have the same thing in parentheses, which you should, you're going to factor that out. So if I factor out q plus 2, okay, so basically I'm taking that away from both parts, then that's just going to leave you with what's left in front, which would be 4r plus 3. That's going to be your final answer. Okay, this one can be a little confusing at first, so I'm going to do a couple more examples just so we have an idea of where to go with it. All right, let's do Rn plus 5n minus r minus 5. Okay, so if you want to move some things around, you can, right? Like if I wanted to switch the order here, I would probably do that so that you could have r in the same group. So I would group those together, and then I would have 5n and 5 in the same group. Now, you don't always have to do it. It is possible to factor it the way it was, but sometimes it's better to group things together that look similar. All right? So on my first set of parentheses, think about what can you factor from both terms. In this case, it's going to be just r. So if I factor r, that would leave me with n minus 1. Right? R divided by r would leave you with just 1. So that's what I want to have left when I factor 5n minus 5. So the only thing I could factor there is the number 5. If you factor that out, you would be left with n minus 1. Right, so just like the other one, we want the same thing left in parentheses, which is what we had. So we're going to factor that out first. So if I factor out n minus 1, then you're going to be left with just what was in front of your parentheses. In this case would be r plus 5. Okay, I'm going to show 2 more examples of that just because I want us to make sure we're really clear. All right, so let's look at 3np. Sorry, I shouldn't have that there yet. Let's do 3np plus 15p plus negative 4n minus 20. All right, so again, here you can go ahead and group it the way that you see it. Think about in that first set of parentheses, what can I factor from 3np and also from 15p? So number parts first, like they're both divisible by 3. What variable can you take from both would be p. So if I factor out 3p from my first term there, I would be left with just n. And then if I factor out 3p from my second term, I would be left with 5. So n plus 5. All right, so when I factor my second set of parentheses, I also want to be left with n plus 5. That means I need to factor out negative 4. If I do that, that's going to leave me with n plus 5. Okay, so again, look inside your parentheses, make sure those things are the same. They are. So we're going to factor out n plus 5. Once I factor those out, you're left with what was in front. So times 3p minus 4. All right, last one like this, and then we'll move on to how do we solve an equation. Okay, so let's look at c minus 2cd plus 8d minus 4. All right, so these are okay to go ahead and group the way they are, so pair those up. Really, the only thing you can factor from the first set of parentheses would be if you factor out c. And that would leave you with 1 minus 2d. Now, here's where you have to be a little careful, right? Notice the way it's written right now, I can't have 1 minus 2d left in parentheses. So you just need to think about, since d is written first here, right? These are kind of opposite of what they should be. Then I want negative 2d plus 1. Because if I have that, that means I have the same thing, okay? So what would I factor out to give me negative 2d plus 1? Well, if you think about what could you divide 8 by to get negative 2, that would be negative 4. So if I factor out a negative 4, that would leave me with negative 2d plus 1. Right? So if I look inside my parentheses, I do have the same thing, they're just reversed, right? So if you were to flip those, you would have 1 minus 2d. All right? So that means I can factor those out since they're the same. You would get 1 minus 2d times whatever you have left in front. In this case, that would be c minus 4. All right, now we need to know this because when we want to solve equations, we need to know how to factor first. So if I have an equation, 2d plus 6 times 3d minus 15 is equal to 0. The way this is written right now, I'm already capable of solving, right? If you have variables by itself, which you do in this set of parentheses, and in this set of parentheses, all you have to do is set each one of those equal to 0. So if I take 2d plus 6, set it equal to 0, then I'm also going to take 3d minus 15 and set it equal to 0. Right, so then all you need to do is solve both sides. So here we're going to subtract 6. I would get 2d is equal to negative 6. Then just divide both sides by 2. So we know d is equal to negative 3. Over here, make sure we add 15 to both sides. I would get 3d is equal to 15. Divide both sides by 3. D is equal to 5. Right, so anytime we get two answers, that means we need to write them inside a solution set. So my two solutions would be negative 3, positive 5. Okay, now they're not always going to be written where you don't have to do any work. Okay, so we're going to look at a couple where you might have to factor first before you can set them equal to 0. All right, let's look at c squared is equal to 3c. Now notice on the last one, we had one side that was equal to 0, so that's always the first thing you want to check for. So all I'd have to do here to get one side equal to 0 is subtract 3c. Right, so that would give me c squared minus 3c is equal to 0. Now remember I told you want variables by themselves, so think about factoring. What could you factor from both terms? to get a variable by itself. In this case, the only thing you could factor out is c. If I do that, what would you have left in parentheses? Well, c squared divided by c would give you just c minus 3. Okay, again, you could just distribute back in. C times c would give you c squared. C times negative 3 would give you negative 3c, if you want to make sure that you did that correctly. All right, so the last thing you have to do is set both parts equal to 0. So c is equal to 0, c minus 3 is equal to 0. Now on this one, obviously, you only have to solve one, which would be to add 3 to both sides. You would get c is equal to 3. So your solution set here would be 0 and 3. All right, let's look at 8b squared minus 40b. All right, so notice this one is already set equal to 0, so you don't have to move anything there. You just need to think about factoring first. What can you factor from both terms? So 40 is divisible by 8, so we want to factor out 8. Both terms have at least one b, so we're going to factor out 8b. So if I factor out 8b from my first term, that's going to leave me with just b. If I factor it from my second term, that's going to leave me with 5. Right, once I get to that step, I just set each part equal to 0. So we would take 8b equal to 0, b minus 5 also equal to 0. On the left, all you would have to do to get b by itself is divide both sides by 8. 0 divided by anything is still 0. On the right side, all you would need to do is add 5 to both sides, and you would get b is equal to 5. Always remember, write your answer inside a solution set. All right, last one. Let's look at x squared is equal to negative 10x. Okay, so think about here. What is it that you want to have your equation equal to? So we always want it set equal to 0. So all you need to do is add 10x to both sides to start. Now remember, those are not like terms, so you can't add them together. So we would get x squared plus 10x is equal to 0. All right, so as soon as you get everything on the same side set equal to 0, you want to factor first. So what can you factor from both terms? In this case, it would just be x. Right, so if I factor out x, I'm going to be left with x plus 10 inside my parentheses, right? Because if I distribute that back in, x times x would give you x squared, x times 10 would give you 10x. Okay, set each thing equal to 0. You would get x is equal to 0 and x plus 10 also equal to 0. The only one you have to solve here is to subtract 10 from both sides. You get x is equal to negative 10. All right, your last step is just to write it as a solution set, which would be negative 10 and 0. Okay, make sure as you go through this that you're careful about your factoring. Anytime you're just factoring something out, you always want to make sure that you factor the greatest thing possible from whatever term you're factoring out of, right? So like think about if you have 8 and 4, it doesn't make sense to just factor out 2 when you could factor out 4 from the total. So just be careful on those. I will answer any questions that you have on Monday. So work through the whole thing, make sure you attempt everything, and then any major questions I'll